Well, hello everyone. This is section 10.2 of Algebra 1, multiplying rational expressions. So last lesson we simplified rational expressions. This time we're going to work on multiplying them together. So if we recall, when we multiplied just any two fractions, we did the numerator times the numerator and the denominator times the denominator. But it was often easier to cross cancel, or as I like to call it, cross simplify first. So we do 4 times 3, get 12, 5 times 7, get 35, and no simplifying we can do, we're done. Same thing in the next one, but rather than starting off and doing 2 times 9, I'd rather do 2 and 10, simplify those to 1 and 5. 3 and 9, 1 and 3. Now we can multiply across and get 3 over 5, and made my life much easier by cross simplifying. Same thing with this last one, 2 and 6, that'd be 1 and 3. And these other ones, m and m squared, we can actually make m 1 and m squared just m. So now we get 1 over 3m. We could have gone the long way as well with that one and done 2 times m on the top and 6m squared on the bottom, and then simplify the 2 and the 6 to 1 and 3, and the m squared to m. And we're going to use that to continue to progress into more new stuff, which is what the third problem already did. So for 2c cubed d over 5ab squared times a squared b over 3cd. And once again, the more we can cross simplify, the better. So cross simplifying here, I can't do the 2 and the 3. 5 can simplify with nothing. So I look for my variables, c cubed and c. Yeah, I can simplify those and get rid of my c, and my c cubed can become c squared. My d and d can reduce and both just become 1 and 1. And my c became 1 earlier. A and a squared, my a can become 1, and my a to the second can become a to the first. My b squared and b, my b can reduce to 1, and my b to the second can reduce to just b. So now if I pick up all the scraps, I have 2 on the top. On the bottom I have 5 and 3. That gives me 15. On the top I have an a and a c squared. So I'm going to write those in alphabetical order, a, c squared. On the bottom, I only have a b for variables. So my answer is 2ac squared over 15b. If I wanted to start that off going the long way again, I definitely could have. And this would be the last problem I show that on. But it would have been 2c cubed d to start, like on the top, 5ab squared. That was the first fraction. Second fraction was a squared b over 3cd. So if we would have multiplied straight top together, we'd have gotten 2a squared b c cubed d. On the bottom, we would have had 15ab squared cd, and we would have needed to reduce from there by subtracting exponents. 2 and 15 don't reduce, but a squared and a, 2 minus 1 is 1. b and b squared, there's more on the bottom, so the 1 that's left over ends up there, or you had a b to the negative 1 that was on top, and you move it back down. C cubed and c, 3 minus 1 is 2, and d, those reduce so they're gone to 1. Let's go on to example 5. Example 5, we notice, wait a second, there's subtraction here and here. So what we're going to have to do is just like when we simplified in section 1, is we're going to look to factor first. So 2x minus 6 can factor to be 2 times x minus 3 by factoring out a 2. Well, now we can reduce this x minus 3 and this x minus 3. And we can also reduce the 7 and 14 to 1 and 2. So on the top we have 2 times 2, which is 4. On the bottom we have 1. So the answer is just 4. So after all of that mess to start, it simplifies to this. 6, same idea, but it gets a little more complicated. The top factors into a difference of 2 squares, being x minus 5 and x plus 5. The bottom, we want to take a GCF out and get 2x squared plus 7x plus 10. Oop, I guess my AirPods are getting low on battery is what it's telling me. We can factor that bottom part further, and we will in a moment. On the next fraction, x plus 2 just stays x plus 2. Now I'm going to go ahead and worry about actually factoring this and rewriting that again. So my x minus 5 and my x plus 5 are going to stay the same on the top of the fraction. The bottom of the fraction is going to have a 2 out in front. To figure out what the other parentheses are going to be, though, we want to do the x. Make it a times c, or 10 times 1 on the top, and b on the bottom. Two numbers that multiply to 10, add up to 7, 5 and 2, or 2 and 5. We can use the shortcut since our a is 1. We have x plus 5 and x plus 2 times x plus 2 on the top, and we're going to factor off this bottom right polynomial or trinomial as well. Negative 30 on the top, 1 on the bottom. This would be a negative 5 and a positive 6, either order as long as the signs stay with the number. So you have x minus 5 and x plus 6. Now we can start looking to reduce again. And we can cross reduce, and we can also reduce vertically. So vertically, x plus 5 and x plus 5 can reduce. Diagonally, or cross simplifying, x minus 5 and x minus 5, as well as x plus 2 and x plus 2. We realize we're left with only a 1 on the top and nothing else. On the bottom, we're left with a 2, as well as x plus 6. And it's actually okay for us to leave our answer like this, since it shows that, hey, we've already exhausted all options to try and factor and simplify. If you wanted to distribute on the bottom and leave it as 2x plus 12, you also could. Either way is acceptable. I'm commonly going to leave it like this, though, in the blue. On to example 7 here. Example 7, same idea. We're going to look to factor first. This left fraction, there's nothing we can factor. Top on the right, we can't factor that, but on the bottom of the right, we can. So we make an x, 15 on the top, 8 on the bottom, 3 and 5, or 5 and 3 work. And I'm just going to go ahead and write that here. M plus 3 and m plus 5 in either order. Well, the m plus 3's can reduce. 5 and 20 can reduce to 1 and 4. The m and the m squared can reduce to 1 and m. Meaning on the top, we're left with 4m, and the bottom, the only thing we're left with is m plus 5 times a bunch of 1's. So we end up with 4m over m plus 5. And reminder, we cannot reduce the m and the m there because 1's part of addition, not multiplication. Example 8, looking for more GCFs on this one. Top left, we can take a 2 out, and we're left with x plus y in the parenthesis. Bottom left and top right, there's no GCF to take out since it's all multiplication. Bottom right, we can take a 3 out, and we're left with x plus y in parentheses. That's quite convenient because those x plus y's can reduce. The 2 on the top can reduce with the 10 on the bottom to make it a 5. And the 5 on the top right and the bottom left can reduce to 1 and 1. If you're wondering, hey, Mr. Kosel, could I have done it in the other way? Could I have done it to where I did the 5 and the 10 and made this a 2 and then do the 2 and the 2? You definitely could, because either way it results to having a bunch of 1's. And they all simplified out. So now we have to deal with xy squared and x squared y. Well, x squared can become x, and x will reduce to 1. Y will become y, and y squared reduces to y. So now if we look through all of the top, we just have a 1, a 1, a 1, a 1, and a y. Meaning if you multiply all those together, you just get y. On the bottom, you have a 1, an x, a 1, and a 3. If you multiply all those together, you end up getting 3x. Getting another warning on my AirPods, that dropped 10% very quickly. But our final answer on this problem ends up being y over 3x. Let's go ahead and go to our last problem here, number 9. Number 9, we have y cubed minus 4y. Well, as we factor this initially, we end up taking a y out, and we're left with y squared minus 4. You might notice, however, that's going to be a difference to two squares, and we'll adjust that in just a moment. As we look at these other ones that we can factor, bottom left, we can factor that with the x again. Top of the x is 4, bottom of the x is negative 4. A negative 2 and a negative 2 do the trick, and we're left with y minus 2 and y minus 2. You do not want to write it as squared because that's going to make it harder to simplify. Top right, we're going to make an x again. Negative 10 on the top, positive 3, negative 2, and positive 5. are the sides we need. So we end up getting y minus 2 and y plus 5. Now let's go ahead and deal with factoring this top left one. And as we're factoring another step, I'm going to write it again. So y, and then y minus 2, y plus 2 from the difference of two squares. My bottom is y minus 2 written twice. And then on my right side, I'm getting y minus 2 and y plus 5 on the top with just y on the bottom. So now I look to cross simplify or simplify vertically. Y minus 2 and y minus 2, y minus 2 and y minus 2 diagonally. Y and y diagonally, meaning I am just left with y plus 2 as well as y plus 5. So I multiply those together, and you can just write it in parentheses, kind of like we talked about earlier on examples 6, and that would be perfectly fine. If you really wanted to FOIL, you could. I would discourage it though, because it'd be more work, and this already showcases that we exhausted all our options. So we'd end up with 2y squared plus 7y plus 10 if you wanted to FOIL it out. Once again, I wouldn't recommend it, and I would just leave this as your answer. All right, that is section 2 in chapter 10.